Here's 5.4. Welcome. Annuities and amortization. Annuities, we kind of talked a little bit about. Amortization is kind of like payment plans, but it kind of all intertwines here. So the present value of an ordinary annuity, it's the payment times all of this. Now notice the negative n power. Notice the minus here. Bring that to your attention because look at the previous section was future value. It's pretty much the same thing, except notice that the top is reversed. It's reversed, and the negative instead of the positive end, because it's kind of like the reciprocal. So it's kind of like the reverse of that, kind of like the opposite. The IC is the same on the bottom. But it's basically the same formula, just slightly changed from the previous one. And so a lot of these formulas, we're just going to take these values here that you see, and we're going to plug them in. So find the present value. Now again, the I again is R over M, interest rate per year, divided by number of compoundings per year. The N is number of compoundings per year times the number of years, M times T. So if you want to find the present value, they're going to give you the information. We're going to take this and put it into a formula. And so as you look at this, I kind of did a little bit ahead here. Now, let's see. Annual payments, $1,200. I'm sorry, the PMT, the payment is $1,200. The annual part is the number per year. So M is 1. T is 10, R is 4%. But when you move the decimal 2 to the left, it's 0.04. So again, we're going to take this information, but we're going to put R over M where I is, and M times T where N is. So I put into the formula the R is 0.04. Luckily here the M is 1. That's nice. And then so here again 1. It's a lot of 1s. So what I did was I simplified it. I divided it. So everything that you see there is circled, kind of get rid of the 1s. And I put parentheses as the calculator is going to have. Well, as it becomes easier for the calculator, is to be able to understand the syntax. And so let's do this. 1,200 times parentheses twice, bracket and red parentheses, 1 minus another parentheses, 1 plus 0.04 close parentheses raised to parentheses. Now here's my negative button. Negative, not minus, not subtracted, negative button. Close the 10 in parentheses. Now put the second parentheses around that red and divided by 0.04, close that guy. And then you have your answer here. So presently, or at the beginning, the annuity was $9,733.07. Now again, if you wanted to use that, if you wanted to use this formula, or this formula up here, to figure out the future value, and here you have the present value, so you can see how much interest was charged, what was the difference, and so that kind of thing. But for right now, this is just present value. So now if you wanted to, you can actually get the present value here. Here, you're given the future value, but now you can use the other information to get the present value if you need the monthly payment. So for this one, it kind of goes in reverse here. So if you know the payment, if you can figure out the monthly payment. So in number 4, if you knew the monthly payment, you could put it in here and find the present value that go along with these future values. But that's not for here. We're not going to worry about that. It's just more work. I think you can see that, but it's not a big deal. It's just multi-steps, and I don't want to go through all of that. I just want you to understand the concept. So quarterly payments, M is 4. The payment, PMT, is 500. The number of years is T, that's 3. The interest rate is 7.1%. So that gives you all your information. So I'll move this other page here, or the other page here, other notebook here. So quarterly, the payment, excuse me, the T, and then the interest rate. Again, you have to move the decimal place 2 to the left. It's tedious, but it comes with the territory. So we put the formula here. The present value will be the payment, which is 500, and then times this big old bracket looking thing. 1, oh, I'm sorry. Let me put it down here so you can see it easier. 1 minus parentheses 1 plus R 0.071 divided divided by M4 raised to the negative M times T, 4 times 3, all that divided by R over M, and all that in a bracket. So let me go ahead and put parentheses here, and here as well. So you can kind of see where I'm going to put the parentheses in the calculator in a moment here. So let's take a stab at this. So 500 times parentheses, bracket, then parentheses, 1 minus, another parentheses, man, you're going to be sick of parentheses before this is all over. 0.71 divided by 4, close the parentheses, and you're going to raise it to, actually, I got to be careful here. I know it sucks, but I have to put parentheses here also. So I need a parentheses, then the negative, then another parentheses, then 4 times 3, then close that parentheses, then close the second parentheses, then close the big red parentheses. Wow. Divided by parentheses 0.071 divided by 4. Close that parenthesis, then close the bracket. And so there's your bad boy. $5,361. $5,361.48. And that would be your present value at the beginning. Okay? And I don't know if we can see as I move this over, number 3 down here. Over here. Monthly, M is 12. Payment, $350. R, 5.4%. Annual interest rate. It'll say annual interest. It doesn't say. I haven't been saying anything about annual, but it's understood to be annual interest rate unless I say otherwise. And then your T is 6 years. So one more time, again, formula. That's essentially what we're dealing with here. 350 times bracket 1 minus parentheses 1 plus R 0.054 over M raised to the negative M times T power 12 times 6 power. All of that enclosure, all that divided by R over M 0.054 divided by 12. And again, parentheses here, parentheses here, and let's have at it. So 350 times bracket parentheses, so parentheses in your calculator, 1 minus open parentheses 1 plus 0.054 divided by 12, close the parentheses. Now you need the exponential here, a little caret top, parentheses, negative, another parentheses, 12 times 6, close that parentheses here, close the red parentheses on the exponent, close the big parentheses on top. All that divided by open parentheses, 0.054 divided by 12, close the bottom parentheses, and then close the big bracket. And that mess is your answer. So we're looking at a present value of approximately $21,484.08. Now the homework and the quizzes on my math lab should be similar. I'm just trying to give you the idea of what to do here, of what to understand. Notice that this chapter is a lot of formulas. Just kind of following through. You should be okay. All right. This is kind of the longest section, so I might have to break it into 2 videos. I don't know. We'll see. Just a little bit. Sorry here. All right, 5.4. Continued, actually. Amortization is the idea that both the principal and the interest are paid by a sequence of equal periodic payments. So amortization is kind of like you're paying off a mortgage, or you're paying off what you owe in sequential payments in the order that you're supposed to pay. Usually we get charged by the month, so go with that. Amortization payments, but again, not always. Amortization payments are the idea, or is the idea, essentially, that a loan of present value, PV, at interest rate per year, or per period, which is your I, may be amortized in n equal periodic payments. PMT is in dollars, made at the end of each period. So now this is the formula. Now the previous formula, as I have it over here. Let's see. Here's the previous formula. This formula right here. Look at the PMT and the PV. What we did here was we took the PV, we took this whole bracket stuff and put it under the PV to solve for the payment. So it's the same formula, just backwards. So it's the same formula I just did, just kind of moving all this over and solving for the payment. So if you know the payment, if you know the present value, can you find the payment? In the previous, if you knew the payment, can you find the present value? So this is the reverse question. And so when you flip everything, when you solve for, put it as a fraction, this becomes reciprocal. So you're dividing by a fraction, so the I goes on top. So you have present value times the interest over all of this. Again, usual rules, I is R over M, and N is M times T. That's not going to change essentially the whole semester. And so you have the average rate of a 30-year mortgage was 3.3%. Examples. On a home purchase of $330,000, if you put a 10% down payment, what monthly payment is needed to amortize the loan? So you're looking for a monthly payment. It's typically monthly. Sometimes you can do semi-annual or quarterly or this kind of stuff, but for the most part, we usually get our bills every month. Okay. So put this on top. Let me write this off to the side here. So the formula. I'm gonna let you have the formulas. Don't panic. Give me a moment here. Okay, that's your formula. Now, number 4, it says 30-year fixed mortgage. So, essentially, for number 4, the mortgage, and I'll put it in your screen in a second. T is 30. Your interest rate was 3.3%. T is 30. Interest rate is 3.3%. So 0.033 is your rate, your time. Now what you need essentially is your M. So as I said before, we're going to go monthly. I probably shouldn't have put the word monthly, but M is 12. So as you do that, the last thing you need essentially is what's the present value. So the present value, here's the thing. You made a purchase of $330,000, but that's not your mortgage because you put a 10% down payment. So the percentage, the present value, the mortgage that you're going to get the mortgage for at the beginning is essentially 330,000 minus 10% of 330,000. This is your down payment. So your down payment, sorry, it's so small there, just to get it fit, is 0.10 times 330,000, which essentially should be 33,000. And you can put that in the calculator to verify it. So this is already paid. So your present value would be 330,000 minus 33,000. 97,000. This is your mortgage, your PV, your present value. That's what you're borrowing. So you already paid 33,000. So now we go to the formula. The payment would be your present value, which is your 297,000, times your I. But now I essentially is R over M. So 0.033 over 12 all that divided, and I usually put a dot there, not that you need it, divided by 1 minus 1 plus I, again, is R over M. Keep saying that. R over M, that's I. And N is M times T, or MT. So M times T. So that's formula. So I'm going to go ahead and put enclosures into what you need to put in your calculator. You need to put a parenthesis around this guy and a parenthesis around that guy. And so let's see. 297,000 times parentheses 0.03. Probably you don't even need the parentheses on top, but I'm so used to putting it there. Divided by 12. Divided by, the bottom you need the parentheses of. You need definitely these in red. 1 minus parentheses 1 plus 0.033 divided by 12. Close parentheses. Now you need your exponential button. Open parentheses, again a negative button, another open parentheses, 12 times 30, close parentheses, 3 parentheses actually, hit equals. This comes out to about $1,300. And not that it really matters, but sometimes you round down, sometimes you round up. This one you round up, but normally you would round up because they want to charge you more. They don't want to undercharge you. But that's semantics. Just round up to the nearest decimal, 2 decimal places. So now let's hit number 5. 5, the same idea. On a $100,000 loan at 4.8% for 20 years, what is the monthly payment needed to amortize the loan? So this one doesn't have down payment. This is just straight up $100,000 loan. So your present value is $100,000. Your interest rate is 4.8%, which is 0.048. The time is 20 years. Now it says, what is the monthly payment needed? So that's your M. Your M is monthly. So there's 12 months in a year. M is 12. So similar formula. Again, this bad boy up here, but with these 2 nuances put in there. So the payment, the monthly payment is 100,000 times I, which is again R over M, close parentheses, then divided by 1 minus parentheses 1 plus R over M, which is the representation for I, 0.048 over 12. All that raised to negative M times T, 12 times 20 this time, not 30. And I shouldn't have put the red one. Or the black one there. To show you that this is what the calculators needs. So this negative here and around. Like that. And so you have here what? 100,000 times parentheses 0.048 divided by 12, close the parentheses, divided by parentheses 1 minus open parentheses 1 plus 0.048 divided by 12, exponential button, parentheses, negative parentheses, 12, open parentheses, 12 times 20, close parentheses, a second close parentheses, and a third close parentheses, those 3, and equals. The payment is almost $650. It's not bad. $648.96. That would be the monthly payment for $100,000. So about $1,300 for 30 years if you want to borrow this much. Now, I know we don't have much time here. But you can actually multiply this payment, because of how much every month, the number of payments will be 240, and you can figure out how much more. In fact, let me do that really fast. Times the number of years times the number of compounds, so times 240. Right. that's actually how much you're going to pay back at number 5. So notice the mortgage or the beginning is 100,000. You end up paying $155,000 back. Okay? Just so you understand, that's the way the world works. That's how these companies get rich, how they make money, because they're giving you 20 years to pay something off. They're going to get something in return. Now, sometimes you can, reanalyze or you can uh, get another mortgage, or calculate a different mortgage, or negotiate a different mortgage. So this number will change, or you can pay more toward the principal at the beginning. So there's a lot of different ways to go about this. But if you just pay straight up the way it's theoretical, you're going to pay an extra $55,000 in 20 years. 55,000 is a lot, but if you look at the scheme of over 20 years, that's really not that much. All things considered, the way we spend money. But I digress. And then finally, here you have your remaining balance. Remaining balance says if a loan can be amortized by end payments of PMT dollars, each at an interest rate per period I, then the approximate remaining balance after X number of payments is this formula. Now, this formula essentially tells you, like, if let's say it's 20 years and you've already paid like 10 years, 12 years, 13 years, 8 years, 15 years, 6 years, and you want to know, man, how much money do I have left to pay? You always want to have an update. This is your formula. So what I'm going to do, what I did, I'm writing it in the other paper. I'm just doing it off to the side. Okay, that's your formula for the remaining balance. A lot of formulas, and I don't really know every formula in business. So I wouldn't expect you to come in and memorize all the formulas. So you can use all of these formulas. So don't panic. Let me do a couple of problems and walk you through. Again, R over M, N is M over T. Now, X is how many payments you've already made up to now, up to the time you want to find out the balance. So that's got to be essentially how much you've already paid. So we'll look into that in a minute. That's the only thing a little bit different here. So if I may, these two problems. The last page here. If the payment is $400 a month for 5 years at 3.9% interest, what is the remaining balance after 2 years? Okay. If I can squeeze this in here. Number 6. Let me go back and forth here. Payment is $400 a month. That's PMT. 5 years. That's your T. 3.9% interest. That's your R. That's not your I. I is essentially interest in every compounding period. This is annual interest, which is R. What is the remaining balance after 2 years? So in this case, now you got to be careful. Number of years paid is, 2 years. You got to be careful because that's not X. N is how many payments you've made. I'm sorry, how many payments you're going to make altogether, which is M times T. X is essentially the same thing, but instead of T being 5, the T is going to be 2 here. So let me explain to you something here. So X is calculated from the number of payments, so a month. So I forgot about M. M is 12 here. So if you've already paid for 2 years and you paid 12 times a year, you have made 24 payments. And I want to give you this kind of weird formula here, but X is the number of payments per year times T. Sorry, times, no, that's not right. I'm sorry, it's not T. X is the number of payments per year times the number of years of paying. That's not, so let me put it up close here. It's how many payments you're going to make a year times how many years you've already paid. That's X. So this person's paid for 2 years. They paid 12 payments a year because M is 12. They made 24 payments. Now, to make this a little easier here, N is M times T. So 12 times 5 is 60 payments. So you need 60 payments. So N is 60. You've made 24. So obviously you have to make 36 more payments. So that being said, let's see if I can squeeze the formula here. It's the payment, which is $400, times 1 minus 1 plus I, which is what? R over M, 0.039 over 12, raised to the negative. Now, N, instead of going M times T, we already calculated here, 60, minus X. X is 24. That's how many payments you've already made. All that divided by, it's easier for the calculations, 0.039 over 12. So let's see if I can kind of squeeze all of this out of the way here. There we go. Okay, needing the parentheses. You need the parentheses here and here. So let's see if I can squeeze all of this into the calculator so you can see it. See that? That makes. Can you see that? I guess you can. I'm sorry, talking to myself here. Times 400 times parentheses twice. 1 minus another parentheses. 1 plus 0.039 divided by 12. Close parentheses. Exponential raised to parentheses negative another parentheses. 60 minus 24. Close that parentheses. Close another parentheses. Close the third parentheses. These three right there. Divided by open parentheses 0.039. Not times, divided by 12, close parentheses, and then close the whole bracket. Oh, wait a second. Oh, yeah, it's 3 parentheses and the last bracket. Sorry, yeah. Second guessing myself here. $13,568.74. $13,568.74. I'm gonna squeeze that in there, right there. And that's number 6. Like these problems, and it's easy for me to say this, they're not difficult. I mean, they're a pain, but it's really like one formula. You just putting the numbers in the right way, make it fit. But it makes it where there's no in between. It's either right or wrong. So you got to be careful. All right, so that's number 6. Let's do one last one here. I don't know if I can do it on the back of this page. Let me make it a little easier. Let's get myself some paper here. I should have probably done them all on the back. But... All right, number 7. If you bought a $225,000 home and you put $25,000 down payment, $25,000 down payment, where your monthly payment is $2,000 at 4.2% for your 30-year mortgage, what is your remaining balance after 15 years of paying? So again, if you bought a house for $225,000 and then you put $25,000 down, $200,000 would be your present value. That's how much you have down. Sorry, wait a second here. I didn't write the PMT part. you know what? In this particular problem, I don't even need the present value. That doesn't matter because you're looking at the payment. It's already broken down for you. So they did it to where your monthly payment's already broken down. Okay, sorry. So this is unnecessary. I just did it extra here. Your payment, your monthly payment, is $2,000. Your interest rate is 4.2%, which is 0.042. The time that you're going to borrow the money is for 30 years, and your remaining balance after 15 years. So X, again, monthly payment, let me come back over here, 12. So X would be the 15 years that you already put times the 12 payments you've already made. So that's 180 payments you've made. Okay? So N would be the 30 years of payments times 12 payments per year. That's 360 payments. So there's N, there's X, there's T, there's R, and there's PMT. So here, balance, or recall the formula being right there, would be what? Your individual payment times 1 minus 1 plus I, which is R over M, 0.042 over 12, raised to the negative N, 360, minus X, 180. All of that divided by I, which is R over M, 0.042 over 12. Okay, so you need a parentheses here and here. So let's see if we can calculate this. I put this thing so you can see off the reflection here. So 2,000 times parentheses 1 minus parentheses 1 plus 0.042 divided by 12, close parentheses, exponential button, open parentheses, a negative sign, open parentheses 360 minus 180, close, divided by parentheses 0.042 divided by 12, close. Wow. So we're talking about $266,755.46. So in essence, I guess I wanted to put this here so I guess you can kind of see. And actually, I think this is probably wrong. I think, honestly, not that it really makes a difference, but I think this should have been 325,000. I think I might have written that wrong. And honestly, this part doesn't matter. But I might have written that wrong there. So let's say the house was 300,000. That's just to give you an idea to compare it to. You paid for half the time and you still owe almost what you borrowed. Maybe this is 400,000. I really don't know, and it's really not important. This is important. Okay, this is the end of chapter 5. Hell of a chapter, huh? 4 sections that I wrote over here. So I'm gonna go ahead and turn it off.